video, we will be studying yet another type of function, okay? We've looked at step functions, piecewise functions, inverse functions. Today we're going to look at a function called a recursive function, okay? Recursive function. So please copy this heading in your notes if you would, please. And this actually should say part 1 right here. So your heading is recursive functions, lesson 6.6, part 1, okay? Recursive functions, lesson 6.6, part 1, and be sure and include today's date so that your notes are organized, okay? Alright, let's continue on. Now, first, let's start off with the definition of what a recursive function actually is. Alright, please copy this in your notes. A recursive function is a function whose domain is the set of non-negative integers. Now, why would I say non-negative? Just listen while you're copying this down. Why would I not say positive? Because if something's non-negative, it's positive, correct? That's not entirely true. The reason we use the word non-negative is your domain is allowed to use 0. And 0 is not negative, but it's also not positive. So if you were to say positive integers, then you're leaving out 0. So we say non-negative integers. Okay? Let's go over this again. A recursive function is a function whose domain is the set of non-negative integers. In other words, the values you put into the function. And by the way, the values you put into a function are called the what? Remember, domain is the same thing as what? Remember, input, okay? So the values you put into the function have to be non-negative, alright? For example, remember back in other lessons I gave you functions like this, remember? And I said evaluate this at f of 4. What value am I putting into the function? 4, so that's my domain. Well, in order to have a recursive function, the values you put in must be non-negative, okay? So that's all that we're saying here. A recursive function is a function whose domain is the set of non-negative integers. In other words, the values you put into the function must be non-negative. Now, also, I would write this down also. If I were you guys, I would write this down and this down also, okay? Also, quite often, you have to know the value of a previous evaluation in order to find the value you're attempting to solve for. Now, I want you to copy that down. That sounds pretty much like Greek right now, but I will explain that in just a couple minutes, okay? So trust me, I will go over that. Also, quite often, you have to know the value of a previous evaluation when you're dealing with a recursive function. When you're dealing with a recursive function, quite often you have to know the value of a previous evaluation in order to find the value you're attempting to solve for. Okay, so today we will be evaluating recursive functions. Let's take a look at one of these. And when we do this one right now, you're going to understand this note right here in just a second, okay? Alright, here we go. Please copy this down. Here's your function. Here's your function. F of n equals f parentheses n minus 1 plus n. There's your function. And I want you to evaluate that at what? 4. F of 4. Now it looks a little weird. Just trust me. Copy that down. And we're going to evaluate it, okay? So I'm going to go ahead and move on. If you need to pause the video, pause the video. So, just like when you have a function like this, if I said to evaluate that at 5, you would simply put a 5 in for x. You wouldn't put anything over here. Well, you could put f of 5 if you wanted to. That's fine. But your final answer would be this. F of 5 equals 9. Okay? Oh, it's the same thing over here in the back page. Here's the main part of my function right So I have f of 3 plus, here's, and I'm going to put what? 4. Do you see what I did? Now if you want to put a 4 over here, I don't usually do that. You're welcome to do that, but you know what that means. all that means is that we're evaluating the function at 4. I would encourage you not to really worry about this in the problems, but you can if you want to. Alright? So, everywhere there's an n over here, I put a 4. Okay? But look what we have. I have f of 3. Do I know what f of 3 equals? Has anyone told me what f of 3 equals? Do you see it anywhere? Not at all. So now you see what this note was saying up here. Quite often, you have to know the value of a previous evaluation, like f of 3, in order to find the value you're attempting to solve for. Okay? So I really can't solve for f of 4 because I don't know what f of 3 is. Now, so you say, okay, no problem, Mr. Earhart. Then I'm going to evaluate this at f of 3, and then once I know what f of 3 is, I can then evaluate the function at f of 4. Well, let's find out. Okay, let's evaluate this at f of 3 and see what happens, okay? Everywhere there's an n, I'm going to put a 3. So put a 3 here, and a 3 here. So 3 minus 1 is 2. That's not going to help, guys, look. Now I have to know what f of 2 is. So the bottom line is this. There's no way we're going to evaluate this function at f of 4 unless I give you some more information. Okay? You have to know one of the previous evaluations in order to solve this function at 4. So, here's what I'm going to tell you now. I'm going to go ahead and tell you. Let me glance at my notes right here. I'm going to go ahead and tell you right now that f of 1 equals 3. So I'm giving that to you. So here's your function. Do you see your function right here, students? There's your function. My goal is to find f of 4. F of 4 equals what? Question mark. I'm telling you f of 1 equals 3. So if f of 1 equals 3, let's work our way up to f of 4. Just watch and see if you figure this out, okay? I already showed you I can't find f of 4 unless I know f of 3. And I can't find f of 3 unless I know f of 2. So I've kind of got a problem here, so I'm going to start. I know what f of 1 is. So let's go next to f of 2, okay? So I'm going to evaluate this function at f of 2. Now, Mr. Earhart, why would you do that? We're trying to evaluate this function at f of 4. I know, but we can't do that unless we find some other values. So let's start at f of 2. That means I'm going to substitute 2 in for n. So here's my n, substitute 2. Here's my n, substitute 2. 2 minus 1 is 1. So I have f of 1 plus 2. Now this is good. What does f of 1 equal? 3. So what can I put for f of 1 right here? 3. What's 3 plus 2? 5. There, we did it. We substituted 2 in, and we got out a value. So that's good. Let's move on now to f of what? F of 3. Let's put 3 in for n. So here's an n, I'll put a 3. Here's an n, I'll put a 3. 3 minus 1 is 2, so now I have f of 2. Positive 3. Do I know what f of 2 is? Sure I do, it's 5. So f of 2 is 5. 5 plus 3 is 8. Now we're getting somewhere. Do you see now what I meant by this last comment? Quite often when you're trying to find the value, quite often you have to know the value of a previous evaluation in order to find the value you're attempting to solve for. I could not find 4 unless I knew 3. Well, I couldn't find 3 unless I knew 2. I couldn't find the value of 2 unless I knew the value of 1. So I gave that to you. Okay? Alright, let's evaluate this function at 4, and we're finally finished. Because that was our goal, wasn't it? Our goal was to find f of 4. So here we go. Here's an n, I'm going to put a 4. Here's an n, I'm going to put a 4. 4 minus 1 is 3, so f of 3. And then for n, I'll put a 4. Now, f of 3 equals what? 8. So for I'll put an 8. 8 plus 4, or 8 positive 4 is 12. So there, I finally solved the problem. F of 4 is 12. Okay, so there we go, we did it. Now that's a recursive function, okay? Alright, let's try another one. Please copy this in your notes. I'm going to move on, so pause the video if you need to. And let's give this a shot. Alright, so here we go. Here's my function right here. There's my function, okay? I'm giving you two values. I'm telling you f of 0 is negative 1 and f of 1 is 3. By the way, notice all the values I put in were non-negative values. Same thing here. All of my values I'm putting in are non-negative. Now, do you sometimes get out some negative numbers? Yes, of course. I have no problem with that. The domain, which is what you're putting into the function, has to be non-negative. Alright? Okay, so I've given you a function. I've given you some starter values to help you. I want you to find f of 5. Well, the best way to do this, trust me students, is just go step by step by step. So you can't just jump to f of 5. Watch what happens if you do, okay? For the n here, I'm going to put a 5. And for the n, I'll put a 5. 5 minus 1 is 4. So I have f of 4. And by the way, there should be a dot here. I apologize. They're being multiplied. So please fix that in your notes. So I'm putting a 5 here. 5 minus 1 is 4. And then times. And then a 5 here. 5 minus 2 is 3. So in order to evaluate f of 5, I have to know what f of 4 is and f of 3. Do you see what I'm saying? So the best thing to do, guys, in these problems is just start at the beginning and work your way forward. We know f of 0 equals what? Negative 1. We know f of 1 equals what? 3. So let's go on to f of 2 and work our way up to 5, okay? f of 2, f of 3, f of 4, and f of 5, okay? So our final goal is to find the value of 5. Okay, let's substitute 2 in for n. 2 minus 1, put a 2 right here, and a 2 right here. 2 minus 1 is 1, so I have f of 1 times 2 minus 2 is 0, so f of 0, okay? What is f of 1? 3. What is f of 0? Negative 1. Multiply them and you get negative 3. Let's move on now to f of 3. So here's the n, I'm going to put a 3. Here's the n, I'm going to put a 3. 3 minus 1 is 2, so I have f of 2 times, and then 3 minus 2 is 1, so f of 1. What is f of 2? Negative 3. What is f of 1? 3. Multiply them together. Negative 9. Now let's find the value of f of 4. We're building up to our answer, which is f of 5. So where the n is, I will substitute 4. Where the n is, I will substitute 4. 4 minus 1 is 3. 4 minus 2 is 2. What is f of 3? Negative 9. What is f of 2? Negative 3. Multiply those two numbers together. Positive 27. Positive 27. Alright? And now, finally our answer, f of 5. So I'll put a 5 right here for n. 5 minus 1 is 4. Put a 5 right here for 4. 5 minus 2 is 3. What is f of 4? 27. What is f of 3? Negative 9. We're going to multiply those together. We'll get a negative 63, carry your 6, 18. I think it's 246. But I will check that with the calculator. But anyways, while I'm checking it, do you see what I did here, guys? I was asked to find f of 5. But I really couldn't do that until I found some previous values first. And that's what I had to do. Okay? And that's very normal in a recursive function for it to be that way. Alright? Okay, 27 times 9. I always want to make sure we get these right. Not sure what happened there. Try that again. And I'm getting 243. That's right. 63, carry your 6 to 43. So negative 243. Okay, so there we go. Now, let's do one more thing, okay? I want you to find the first 5 values of this recursive function. The first 5 values. No one ever says that. It does. Are you listening, guys? It does not mean to start with 0 or 1 or 2 or 3. It means start with the value they give you and find 5 values. So we already found 1. All we have to find are 4 more. So f of 4, f of 5, f of 6, and f of 7. Okay, that's the first 5 values. So here we go. Let's try to evaluate. I started with 4 because they gave me f of 3. They're telling me f of 3 equals 9. Here's my function right here. Okay, so I'm going to substitute 4 in for n. So I'll put a 4 here. 4 minus 1 is 3, so I have f of 3. And then plus 4 squared, right? We're putting 4 in for n. So 4 times 4 is 16. And then negative 4. Now what is f of 3? It's 9, right? So I have a 9 right here. So positive 9, positive 16, that's 25. Minus 4 is 21. So there we go. So f of 4 equals 21. Alright, let's go ahead and evaluate now. F of 5. So I'll put a 5 right here. 5 minus 1 is 4. So f of 4 plus, we're putting a 5 in. 5 squared is 25, so positive 25. And then minus n is 5, so negative 5. Now, what is f of 4? Well, it's 21, so I can really put 21 right here. Okay, 21 and 25 is 46. 46 minus 5 is 41. So f of 5 equals 41. By the way, in your homework tonight, when they ask you to find the first 5 values, I would strongly encourage you to check each value as you go, because think about it. If you miss 4, 5 is based on 4, so you'll miss 5, and then 6 is based on 5. I would have your answer book open, the back of the book, and check each number as you go. Find f of 4, then make sure it's right, then f of 5, make sure it's right. Okay, alright, now we're going to evaluate f of 6. So I'll put a 6 right here. 6 minus 1 is 5, so f of 5 plus, now for n, I'll put a 6 right here. 6 squared is 36. And then negative n, that's negative 6. Okay, what does f of 5 equal? 41. So 41 plus 36 is 77 minus 6, which would give you 71. Okay? Alright. And then lastly, f of 7. Alright? So I'll put a 7 right here. 7 minus 1 is 6. Put a 7 right here. 7 squared is 49. And then minus 7. Alright? F of 6 is 71. So 71 plus 49 would be 120. And 120 minus 7 would be 113. I believe I did that quickly. We'll check it here real quick. 71, 120, yes, 113. Okay, so there we go. We found the first 5 values of the recursive function. Here they are right here. You could write your answer like this if you want to. Have no problem with this. Just list them out. 9, 21, 41, 71, and 113. In fact, that's how the book has their answers written. Okay? Alright, guys, that's it. What we're focusing on today. Now listen, the next video we're going to do from lesson 6.6 is based on today's math. So I really want to make sure you understand how to evaluate recursive functions, or you're really going to be lost in the next video. So make sure you understand this and do well on your homework.